This is working with lists in Python. In this screencast, I'm going to show you how to work with lists of data in Python, manipulate them in various ways, and to provide access to your application's various types of data that can be stored in lists. Okay, so I'm going to do all the code for this screencast in the Python interactive shell. I'm using Python 2.7, and I'm just going to type a few things in really quick so you can kind of get a sense as to how this works. Basic idea is you want to use a list to store multiple things in a single variable. So I can create a list called myLists, and the syntax that you use to create a list involves putting one or more things in a set of square brackets. In this case, I'm going to add three elements of text, but lists are very versatile in Python. There's no limits really in terms of what you can store in a list. You can store strings, you can store numbers, you can store objects, all that stuff. But just to make this easy and straightforward and obvious to start off with, I'll go 3 different types of fruits. And the other thing that I want you to pay attention to is the fact that I did not type these in any order. They're in reverse order, actually, reverse alphabetical order. But you can see that I've assigned these 3 items to the list, and if I just type in my list, it'll echo it back to me and it'll tell me what's inside the list. Now, this is interesting, but there are more meaningful and more interesting things that you can do with lists. For example, you have 3 items in the lists, and in any programming language, almost any programming language, items in this kind of construct are numbered. We call the numbers indexes, and the indexes almost always start at 0. So you can say that I have a list comprised of 3 items, and the items are numbered 0, 1, and 2. Okay, how do I see the 0th, or the first, I guess, item in the list? You can say my list of 0 is how we say this, and it shows you the 0th item in the list. The first item in the list, my list of 1, is that, and we go my list of 2, and that's the third one. What happens if we go my list of 3? There is no third item in this, so it's an error, right? List index out of range. It means you tried to access an element of the list that does not exist. This is a list, remember, comprised of 3 items, but their indexes are 0, 1, and 2, so there is no item 3 in the list, and so attempting to access an item 3 in that list is going to generate an error, and we would expect that. Now let's say we want to figure out how many items are in the list. We can say len, which is length, and that tells us that we have an item of length, or a list of length 3. Okay, so now one of the most common operations that we can do here, now that we have the ability to create the list and we also have the ability to determine how long the list is that we can create a loop that will go and visit each member in the list. This is called iterating over the list, because you're going through the list one item at a time and doing something or outputting something from that list. So in Python, iteration is always done with for, and I can say I need a placeholder variable to store each item in the list, and I'm going to call each item fruit. And then I need to say that this is going to go into a range. And range is a really versatile function in Python. You see it happen all the time in lots of different constructs. But basically what we're trying to do is we're trying to say start here and end here, and that's the definition of the range. And so the definition of the upper bound of the range is going to be the length of the list, which we calculated earlier. And I'm going to put a colon on the end here to indicate that I'm creating a multi-line block, which means that when I hit enter now, nothing's going to happen. I have to indent, and I'll say print my list of fruit. And you can see that that fruit gives me an index into the list, which is called my list. So each time, for each member of the list that I visit, it's going to give me 0, then 1, then 2, and then it'll be done. But the reason why we do it this way, instead of saying for fruit in range 0 to 3, is we want this code to work no matter how many items ever get added to the list, right? So this loop is a good all-purpose way of getting access to all the items in the list, and you can see that it iterates through all the items in the list and gives me the ability to see everything that's in there. Okay? Now what happens if we wanted just a subset of the list? We can actually pretty easily slice and dice lists, and Python provides a lot of really handy convenience functions to do that. Here's a good example. Print my list, and I'm going to give it an index, but I'm going to delimit this with a colon. 0 to 2. Starting at the 0th member and ending before the member with index of 2. And that's a tricky thing about slicing lists like this, is that when you say 0 to 2, the number of items you're going to get is 2, and those indexes will be 0 and 1. Okay? What happens if we do something like this? Print my list from 0 to 15. Now again, you saw earlier that when we tried to access item 3 in the list, it wouldn't let us. It was an error, right? But what happens if we create a construct that says, show me everything in my list from 0 to 15? This time it's not an error. It actually gives us the entire contents of the array without generating an error. In this case, it just figures you overshot, and since you're not specifically referring to any particular item in the list, it gives you the entire contents of the list. Now this is tricky to rely upon, right? Because if we ever had a list with more than 15 items, this code would stop working. But if you had some sort of fixed list that you didn't plan on changing and things like that, this is one way to do it, and you can overshoot, and that's no big deal. Now, you can even create the lower bound beyond the end of the list like this. You can say print my list from item 14 to item 15, and this is not an error either. Even though the beginning point and the end point is totally out of the boundaries of the list, it's still legal to use this construct. And you can see that what's going on here is that we're getting back an open and closed pair of square brackets, which is the symbol for an empty list in Python. So basically slicing a list like this will always return a list. The list may be empty, but it will always return a list, and it doesn't return an error. Okay. Now how do we add stuff to a list after the list has already been created? This is another really nice flexible thing about Python lists, is that you can append stuff to an existing list, and here's how we do this. We can go mylist.append and add a fruit to the end of the list, and then I'll say my list, and you can see now I have 4 items in my list. I can add another item if I want to, and I can just go on and on. And there's no limit to this. Okay, so now I'm going to show you a couple of things about how to sort a list. I closed and reopened Python, so what you see on my screen is a little different, but the list that I created is the same list, and I can do this by just printing it out like that. You can see we have 5 different fruits, and they are in no sorted order, but we may want to sort them. And we have a couple of choices here in terms of how we want to do this. One of the things that we can do is called an in-place sort, which is to change the arrangement of the items within the list. But another way we can do this is to return a copy of the list in sorted order, and that can be advantageous because it preserves the original data in the list and leaves, if that's meaningful to you for some reason, then you can do that as well too. So there's 2 functions that we can use to do this: sort and sorted. I'll do sorted first because that leaves the original list in its original state. And so to do this, I have to set it to a return value, which will be a new copy of the list that will exist in sorted order. So I'll say sort list equals sorted my list. Okay, so now I have 2 lists. One called my list, which is the original list, which looks like this, and then another one which is called sort list, which looks like this. And you can see that it's been sorted into alphabetical order. Now what happens if you want to sort the original list? This is what we call an in-place sort. All you have to do is use the sort method of the list variable. So we say mylist.sort. and now my list is also sorted in alphabetical order. There are different options here too as well, because you can sort by alphanumeric, numeric, custom function sorts. There's a lot of different flexibility that you have here. One common way to do an alphanumeric sort is to sort by is to put everything into lowercase. And so to do that, you can say mylist.sort and then say key equals str.lower. And you see this a lot because this is the way to get an alphanumeric sort. You can see it doesn't change the sort order of the list that we happen to have here, but if you had items that were in the list that had a combination of uppercase and lowercase characters, this would cause them to sort the way that you would expect them to be sorted. And there's a lot of depth and a lot of complexity to sorting like this. You can, like I say, you can write custom functions that applies specific rules for sorting things and so forth. You would think that sorting would be pretty simple, because there's really kind of only, there's one way to sort numbers, there's one way to sort values that are textual and things like that, but you can actually, because you can store almost anything in a list, sometimes you have to write these custom sort functions. And to give an example of this, you can say, here's another list, and we can say this list is going to be comprised of a string, which is the word shoes, and the number 4, and the number 6, and a holiday treat, like that. And that works. You can put any kind of data that you want into a list, and it'll just take it. Right. So in a world in which this is the case, you have to then kind of decide what sort is going to mean. Right. And it'll try to do its best. In this case, it sorts first by numeric and then by textual, but maybe that's not what you wanted, in which case you could write a custom sort function to do that. And that's beyond the scope of the screencast, but just to kind of give you a sense as to the power of lists and the power of sorting in Python.